So in this video, we'll talk about geometric sequence. So ano ba ang geometric sequence? A sequence where each term is found by multiplying the previous term by a constant. Example, 2, 4, 8, 16. Notice that the next term is found by multiplying the previous term by 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so forth. Now, we call that constant multiplier the common ratio. Sometimes you would want to get the common ratio in dealing with geometric formulas. So how do we get the common ratio given the sequence? So madali lang, no? Just divide any two consecutive terms, but make sure that you divide the succeeding term by the preceding term. Meaning, yung sinusundang term ang i-divide natin doon sa sumusunod. So we have 4 divided by 2, or 8 divided by 4, or 16 divided by 8. All of them are equal to 2. That is why it is called the common ratio. So we say R is equal to 2. Next to consider are the common problems we encounter in geometric sequence. So just like in arithmetic sequence, for every problem, there is a corresponding formula. Now, common mistake ng bata, ginagamit yung formula ni arithmetic sa geometric and vice versa, which is very wrong. So, yung pong kay arithmetic lang. At yung kay geometric lang. Huwag niyo po silang paghahaluin. Okay? So, let us now go back to our problem. Supposing we are given the geometric sequence 2, 4, 8, 16. And supposing we are asked to find the 10th term, what is the corresponding formula? The corresponding formula in finding the nth term is a sub n is equal to a sub 1 r to the n minus 1. So we will give examples later, no? Ilalatag muna natin lahat yung mga formulas natin. Another problem to consider is finding the partial sum. So supposing, again, we are given the geometric sequence 2, 4, 8, 16, and we're asked to find the sum of the first 10 terms, no? So we have 2 plus 4 plus 8 plus 16 up to the 10th term. What is the corresponding formula? The corresponding formula is S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. Now, kung meron tayong partial sum, meron din tayong infinite sum sa geometric, no? And this is only applicable for decreasing sequence, meaning descending ang sequence natin, which means that the absolute value of r must be less than 1. So, supposing, again, binigyan tayo ng geometric sequence pero pabalik, no? We have 16 plus 8 plus 4 plus 2. And we're asked to find the infinite sum. The formula for the infinite sum is a sub 1 over 1 minus r. Okay, so let us apply this formula by considering the following problems. Problem number 1, determine the next two terms of the following geometric sequence, negative 1, 1/3, negative 1 over 9. Now, para makuha yung next two terms, kailangan isolve muna natin ang common ratio. And to get the common ratio, we simply divide any two consecutive terms. So, wag na tayong lumayo. Let us choose negative 1 and 1/3. By the way, we divide the succeeding term to the preceding term. Yung sinusundang number ang i-divide doon sa sumusunod, no? So, to solve for r, we divide 1/3 by negative 1. So r is equal to 1/3 divided by negative 1 or negative 1/3. Now, to get the next term, multiply lang natin yung negative 1 over 9 sa ating r. So negative 1/9 times negative 1/3 is equal to 1 over 27. And to get the next term, we multiply 1 over 27 again by negative 1/3. So that is equal to negative 1 over 81. So the next two terms are 1 over 27 and negative 1 over 81. Problem number 2, insert 4 geometric means between 3 and 96. So again, to insert geometric means, kailangan natin i-solve uli ang R. So to solve for R, position natin yung mga terms. So we have the first term 3, and then put spaces here for spaces. And then the last term is 96. Meaning 3 is our first term and 96 is our sixth term. Now, to solve for R, gagamitin natin itong 96, no? By using the formula for the n term, a sub n is equal to a sub 1 r to the n minus 1. So, a sub 6 is equal to a sub 1, which is 3. R is unknown. N is equal to 6. Now, since a sub 6 is equal to 96, substitute natin yan. So, we have 3r to the fifth. And then to solve for r, we divide both sides by 3. So, r to the 5 is equal to 32. So, if r to the fifth power is 32, then we get the fifth root of both sides. And the fifth root of 32 is 2. Therefore, r is equal to 2. Now, to get the geometric means, we simply multiply the first term by 2, which is equal to 6. Then, to get the third term, again, multiply 6 by 2, we have 12. Again, multiply by 2, we have 24. Multiply by 2, 48. As you can see, if we multiply 48 by 2, we get 96. Which means that the 4 geometric means that we solved are correct. Problem number 3. If a sub 5 equals 1 over 8 and a sub 8 is equal to 1 over 64, find r. So here, given tayo ng dalawang terms, a sub 5 and a sub 8. Now, if a sub 1 is given, this could have been easier, no? So pag wala ang a sub 1, paano natin solve ang r? So again, we'll make use of the formula for the nth term, which is a sub n is equal to a sub 1 r to the n minus 1. Now, if a sub n is equal to a sub 5, then a sub 5 is equal to a sub 1 r to the 5 minus 1. Since a sub 5 is equal to 1 over 8, substitute natin. It is equal to 1 over 8 is equal to a sub 1 r to the 4th. So this is our equation 1. Now, if a sub n is equal to a sub 8, then a sub 8 is equal to a sub 1 r to the 8 minus 1. But since a sub 8 is 1 over 64, then 1 over 64 is equal to a sub 1 r to the 7. So this is our equation 2. Now, how do we solve for r? Well, we can do this in two ways, no? Pwede natin isolve to by substitution. We can solve for a sub 1 in equation 1, then substitute a sub 1 to equation 2. Pero, meron mas madali, no? We can easily divide equation 2 by equation 1 and look what happens, no? So we have 1 over 64 equals a1 r to the 7. That is our equation 2. Equation 1 is 1 over 8 is equal to a1 r to the 4. Now, if we divide 1 over 64 by 1 over 8 and a1 r7 by a1 r4, 1 over 64 over 1 over 8 is 1 over 64 times 8 over 1. So we can cancel 64 and 8. Nangyayari, 8 na lang to. That is equal to 1 over 8. For the right-hand side of the equation, cancel ang A1. We are left with R7 over R4, which is equal to R cubed. Which means that 1 over 8 is equal to R cubed. Now, to solve for R, we simply get the cube root of both sides. Therefore, R is equal to cube root of 1/8 or 1/2. And that's it. Problem number 4, find the 11th term of the geometric sequence with a sub 1 equals 64 and R is equal to 1/2. Again, para mahanap natin ang 11th term, we use the formula for the nth term, which is a sub n is equal to a sub 1 r to the n minus 1. Since we're looking for the 11th term, then a sub 11 is equal to a sub 1, which is 64. R is equal to 1/2 to the 11 minus 1. Now, this is equal to 64 times 1/2 raised to 10. So, this is equal to 64. 1/2 raised to 10 is 1 over 1024. Now, we can cancel 64 and 1024. So, this is 1 and this is 16. So, the answer is, the 11th term is 1 over 16. Okay? Problem number 5, find the sum of the first 5 terms of the geometric sequence, square root of 2, 2, 2 square root of 2, and so on and so forth. Now, since we are looking for the sum, ang gagamitin nating formula ay sa geometric series, which is S sub n is equal to a sub 1 times 1 minus r raised to n over 1 minus r. Now, since we need r, let us solve for r by taking the second and the third term, no? Para mas madali. So, let us divide 2 square root of 2 by 2. As you can see, cancelled lang on 2. Therefore, r is equal to square root of 2. So, let us now take S sub 5 since we are looking for the sum of the first 5 terms. A sub 1 is equal to square root of 2, our first term, times 1 minus r, which is also equal to square root of 2, raised to 5, over 1 minus square root of 2. Okay, let us simplify by multiplying square root of 2 by 1 minus square root of 2 raised to 5. We can use distributive property. Square root of 2 times 1 is square root of 2. Square root of 2 times negative square root of 2 raised to 5 is negative square root of 2 raised to 6. Remember, no? When we multiply, we add exponents over 1 minus square root of 2. Now, but what is square root of 2 raised to 6? Square root of 2 raised to 6 can also be written as the square root of 2 to the 6. Pwede natin ipasok sa loob yan, ano? And 2 to the 6 is equal to 64. And square root of 64 is equal to 8. So let us now substitute 8 here. So we have square root of 2 minus 8 over 1 minus square root of 2. Now, since the denominator has a radical, we need to rationalize this by multiplying both the numerator and the denominator by the conjugate of the denominator, which is 1 plus square root of 2 over 1 plus square root of 2. So, applying the FOIL method, first term, square root of 2 times 1 is square root of 2. Outer term, square root of 2 times square root of 2 is positive 2. Inner, negative 8 times 1 is negative 8. And the last term, Negative 8 times square root of 2 is negative 8 square root of 2. Over, so since this is a product of sum and difference, we only need to multiply the first terms and the last terms, no? So 1 times 1 is 1. Negative square root of 2 times square root of 2 is negative 2. So the numerator is, we can combine square root of 2 and negative 8 square root of 2. That is equal to negative 7 square root of 2. Plus 2 minus 8 is negative 6. Over 1 minus 2 is negative 1. Now, dividing both terms by negative 1, we have 7 square root of 2 plus 6. And that's it, no? 7 square root of 2 plus 6. Okay, last number, problem number 6. Find the sum of the geometric series 1 plus 2/3 plus 4 over 9 plus dot, dot, dot. So, the presence of ellipsis here indicates that we are looking for the sum of an infinite geometric series. And since r is equal to, if we take the second term and the first term, dividing 2/3 by 1, that is equal to 2/3. So, pasok ang r natin sa formula ng infinite geometric series. Because in an infinite geometric series, remember that the absolute value of r must be less than 1. Okay, so let us now take the infinite sum that is equal to a sub 1 over 1 minus r. But since a sub 1 is equal to 1 and r is equal to 2/3, then that is equal to 1 over 1 minus 2/3. But 1 minus 2/3 is equal to 1/3. And 1 over 1/3 is equal to 1 times 3 over 1 or 3. Okay?